So today we're going to look at lights, and all the ways that we need to illuminate a studio. And by lights, I'm kind of talking about all these little instruments that you see just sort of hanging up on the studio behind me. So what we're going to basically do is just kind of cover a little bit of what lighting has to entail. So when I talk about lighting, we're going to talk about the properties of lighting for television. So one of the things is that when we're dealing with the color of lights, we're mainly dealing with three main colors: red, green, and blue. Now, your eyes can see an entirely larger spectrum of those, but in the world of television, it kind of gets broken down into these three simple things. Now, in order to see light, or in order to see color in objects, what you're seeing is not just, you're seeing the only color that's being bounced off that, and all the other colors are being absorbed. So whenever we look at like a white surface, the entire spectrum of light, such as the red, white, yellow, green, are all getting bounced off a white surface, and that is being reflected back to you. That's one of the reasons why a white surface is so extremely bright. Now, if we look at a light reflected off of a black surface, it doesn't actually reflect the light, it actually absorbs it. So most of the wavelength of the white light gets absorbed into the black, and it does not reflect it, which is why black color is just kind of harder to see. Now, when we get into specific colors and color temperatures, what happens is, like in the case of this red surface, the entire spectrum of light is getting bounced to it, and everything is getting absorbed except for the red. So when you look at an apple and the apple appears to be red, you're seeing that that apple has absorbed all the color ranges except for red. That's what's being bounced off and going into your eye. And then inside the back of your eye, you have many different types of photosensors. And the main two that we deal with are called cones and rods. So the cones function, and they function best in bright light because most of the light and information can get to them. So cones and rods kind of work on darkness and light as well as working on different aspects of colors. So that's the reason why, like if you look at a banana appears yellow, because it's absorbing that entire spectrum of light except for yellow, and then it's bouncing that yellow to your eyeball where it's being received by the cones and rods, and thus you see that. Now, the thing is, you can't see without light. You can't see in dark areas with the naked eye, or it's harder to see the darker it gets. Well, a camera is the same way. Now, whereas you have cones and rods in the back of your eye, a camera has a chip called a CCD. And this CCD is what's capturing the eye. So basically, when you're seeing an image based off when you're seeing light color based off an image, that camera is seeing pretty much the same thing, and it has color sensitive chips, red, green, and blue, that it's using to capture those channels and then record it for playback later. Now, one of the things that comes into play when you're dealing with seeing objects in light is what's called a contrast ratio. Now, with a contrast ratio, this is a ratio of light to dark, and the greater the contrast ratio, the more that you can see. Now, when we're dealing with the human eye and human vision, we actually have two ratios going on at the same time. Whenever you look at something, you never stare at one pinpoint moment. Your eye is always just kind of moving around a little bit and picking up a bunch of different little pinpoints. And these are very minute muscle movements that your brain doesn't really interpret as movements, but it is able to grab all that information. And this is what's called the static ratio, these little pinpoints, and that's about 100 to 1 for a single image. But while your eye is moving around, it's picking up so many more points, and this is what's called your dynamic ratio. And this is what's including things like your peripheral vision off to the side, and other things that are happening kind of above and below, just out of your straight line of vision. So this is what's called your field of view, and this is everything you see, including that one single pinpoint that your eye is looking at momentarily. And your dynamic range can get up to about 1,000,000 to 1 field of view. And this is processing over time. This is not a single snapshot of an instance, because as you take in information, you're looking at things on your right peripheral that you may not see in your left, and then your left will catch up. So your peripheral and your dynamic is building up over the course of time. Now, cameras, on the other hand, they don't have the ability to do the static and the dynamic. They just have a broad static, so they can look at kind of one thing at a time and they record that. So for cameras, their aspect ratio only works in a range of about 1,000 to 1 to 2,500 to 1. And so this is one of the reasons why we tell you not to shoot in front of a window. In the case of dynamic ratio, when I look out a window and I see a computer in front of a window, my brain is able to look at the lighting that's inside, the darker lighting, and then it can look through the window to go to the lighting outside and see the brighter lights. And so in your brain, you're able to see both dark areas and light areas due to your dynamic ratio. Now, in the world of cameras and static ratio, they can do one or the other. They can see the light inside or the light outside, but not both. So in this middle image, I can see that I've got my computer on my desktop, but if I look out the window, it's so overexposed I can't tell what's going on. And that's because the camera has set the aspect ratio for indoors to be brighter, so you could see it. But the consequence is it overexposes outdoors. Likewise, if you take the iris and you pull the iris down, then you're pulling down how much light comes into the camera. And when it does that, it's going to make the inside darker, but you're able to see the outside because the camera can only do one ratio, either indoors or outdoors. And because of this is why we tell you not to shoot in front of a window, because the camera can either give you a good outside or a good inside, but it cannot give you both. So this is an example of a story where a reporter was trying to shoot both indoors and outdoors, and the contrast ratio was really hard to get.
Just off U.S. Highway.
So I'm going to disappear and let you guys watch.
Highway 231 in Troy. If you follow the smoke from its chimney, you'll find Hook's Barbecue. This local favorite has found its way into the Alabama Tourism Department's book, Alabama Barbecue, Delicious Road Trips. And its loyal customers know why.
I got some North Alabama roots, and I've always enjoyed barbecue North Alabama. And this reminds me of that barbecue as well.
I like the sauce on it. It's just a great taste.
Just off U.S. Highway 231 in Troy. If you follow the smoke from its chimney, you'll find Hook's Barbecue. This local Just off U.S. Highway 231 in Troy. If you follow the smoke from its chimney, you'll find Hook's Barbecue. This local favorite is found just off U.S. Highway 231 in Troy. If you follow the smoke from its chimney, you'll find Hook's Barbecue. This local favorite has found its way